So in today's experiment, we're going to use acetic acid. And acetic acid is a weak acid. It has a pKa value. A strong acid is fully ionized and does not have a pKa. So I've drawn the structural formula for acetic acid here, reacting with water to protonate the amphoteric water molecule and give us the acetate anion. And this equilibrium is established when you dissolve acetic acid in water. Now, with a weak acid, the majority, this equilibrium lies to the reactant side. Most of the acetic acid in solution exists as the acetic acid molecule and not as the ionized form. We can write an expression, the acid dissociation constant, the Ka, and for any reaction, we can write a equilibrium constant, and it is equal. The equilibrium constant is the concentrations of the products, and if there is a coefficient, now here our coefficient is implied, it's implied to be 1. You write the concentration of the products raised to the power of their coefficients. Now, in Chem 100, we don't do any experiments where the coefficient isn't 1. But I just mentioned this because someday, if you see an expression that has a squared or a cubed or fourth power up there, that I want you to know where it came from. It comes from the coefficient here. You don't need to worry about it. Ours are all 1. So it's products over reactants and excluding the solvent, excluding water. And this is the experimentally determined value of that acid dissociation constant. So this is a very small number, 2 times 10 to the minus 5. So it's, get my pen back, 0.123 That's my 5th decimal place. I'm just going to check this. 1, 2, 3, 4, 5. That's not a 5. I apologize. That's a 2. 2 times 10 to the minus 5 is this number. And you recognize this is a very small number. So most of the acetic acid is unionized. This concept will be important later on when we're doing simplifying assumptions to solve some equations. That's why I want you to pay attention to the fact that this is such a small number. And then if we take the log of this very small number, we get a negative number, and we change the sign. So the p-value is the negative log of the number, and we get 4.7. And note, this has one significant figure. So the mantissa of our logarithm has one significant figure. So that's how we end up with 4.7. And remember, this is the mantissa of the logarithm, and this is the characteristic of the logarithm. If this doesn't ring a bell, go back to the videos on the titration of acetic acid. I think that's where I discussed that.